enters the atmosphere of Mars. So there's the control room to your left. There's a live animation giving a sense of what is going on with that spacecraft at the moment. What you're not seeing is things are getting very hot right now. Steve Squires, take us through this process of going from 20,000 kilometers per hour, 12,700 miles an hour, to zero in 7 minutes. That's a lot of heat. The trade-off is heat, isn't it?
They just hit the top of the Martian atmosphere about 30 or 45 seconds ago. They're expecting to hit the peak heating, which will be about 2,600 degrees on the heat shield, within the next minute or so. Now, of course, that's as we see it here on Mars. As we see it here on Earth, it happened on Mars 16 minutes ago. Basically, what you're doing is you're taking the velocity of the vehicle, its kinetic energy, and you're converting it to heat, and you're dumping that heat to space, and that's the way the vehicle slows down.
In this case, what are the big worries? For one thing, it has gone to battery power. The batteries are operating. Right. That's a good thing. Communication is key here. You will, in theory, the team should be able to see this spacecraft pretty much go all the way down with a few hiccups along the way.
There might be a blackout during the period of peak heating when you develop plasma, a sheath of plasma around the vehicle. It's hard to punch a radio signal through that because the atmosphere gets so hot. Once that cools off, they should see the signal again, and then when the parachute deploys, all of a sudden they'll start seeing data coming down at 32,000 bits per second, and they should have a lot of information from there all the way down to the ground. That'll happen in the next couple minutes.
When you say 32,000 bits per second, they're going to know everything about this spacecraft. And one of the things going back to December of '99 and the loss of Mars Polar Lander was they were completely in the dark as Polar Lander went down. They didn't have the orbiting assets. They didn't have the capability of watching it. And as a result, the failure was really a mystery, wasn't it? This is important to be, if nothing else, even if it doesn't succeed, to know what happens, right?
Yeah, they should have lots of information starting very soon about what's going on with their vehicle, and succeed or fail, they will know what happened.
All right, as a principal investigator at this point, I mean, you're not even driving the spacecraft. No one's driving the spacecraft. But as you're the science guy, you're all about the payload, not the spacecraft getting it there. So you really are kind of powerless at this point, aren't you?
Yeah, everybody's kind of powerless at this point. It's in the hands of Mars at this point.
15 minutes for the signal to get up to 10 hours. So Phoenix now 2 minutes and 25 seconds past the entry point. We still have a signal via Odyssey, standing by for reacquisition via direct to Earth.
All right, you heard that call. That comes from Richard Cornfield, who is one of the mission commentators. And he is saying that so far everything is good. And as a matter of fact, the signal has gotten to Mars Odyssey, which is in orbit of Mars. Tell us what the significance of that is.
Yeah, what that means is that the vehicle, the Phoenix vehicle, as it's descending through the Martian atmosphere, is successfully communicating with an orbiter overhead. That's really good news. That means the vehicle is still alive and doing well.
All right. At what point in this descent, pretty soon for now, I think, we're going to have a parachute deployment. What time does that happen?
Very soon, like within the next 10 seconds. Stand by.
In 10 seconds.
This will be a moment that everybody will be on the edge of their seats there in that control room here at the Jet Propulsion Laboratory. There you see that live animation, which depicts what's going on with the spacecraft right now. It looks like an Apollo capsule.
Odyssey switch to say 2K detected. We are Odyssey locked up on the Phoenix carrier. Standing by for expected parachute deployment, and Phoenix switch to say 2K. At this point in time, Phoenix would have normally deployed its parachute, standing by for telemetry acquisition.
All right, we don't know for sure if that parachute is deployed, that supersonic parachute. The spacecraft should be going about 1.5 times the speed of sound on Mars. That is a high-speed parachute. We're waiting to hear if it's going to deploy. Key moment right now, and it looks like the team is indicating they got it. They got it.
All right.
Phoenix switch to say 2K detected. We have data lockup.
All right, heat shields away.
Parachute deployment trigger detected. Heat shield trigger detected. Ground relative velocity 90 meters per second.
Next thing is the radar is going to pick up the surface.
All right, so the radar altimeter, of course, the only way to know where the surface is to bounce your own radar beams off of it. It's important that this work just according to plan. And then, of course, the next key thing after that will be the separation from that parachute with the shell on top of it, right? It drops, literally starts dropping like a stone.
Yeah, 37 seconds before touchdown, they're going to cut that thing free, and it starts flying on its own.
And that'll be a dicey moment because the rockets don't start firing.
That's right.
Until
those rocket motors are going to fire or they're not, and we're going to find out in 1 minute and 31 seconds.
All right. very key that that radar altimeter turns on.
On and altitude convergence.
Okay, radar's on.
Radar switch to altitude mode.
About how fast would it be going now? It's slowing down pretty quickly.
Yeah, it's getting down to a couple hundred miles an hour, something like that.
Yeah, but still dropping very quickly because you got to remember the Martian atmosphere is much, much thinner than our own.
That's right.
So that
you do not drift down lazily on a parachute on Mars. They're screaming down towards the surface.
As your guest there is indicating, is that the data link...
Land leg deployment trigger detected. Ground relative velocity 60 meters per second. Standing by for altitude convergence.
All the way down to the surface, but I think...
Now, I've not heard a confirmation that that radar altimeter is working. We don't know yet, do we?
They're still working on that one.
Just seconds now until landing.
There you see Peter Smith there, the principal investigator, Charles Alachi in the foreground there, head of JPL. I think you wrote in your book that all the managers come in because they can, right? That's why they're there. But this is
Phoenix have normally reached
their baby as well, isn't it?
Standing by for confirmation via telemetry.
Radar reliable. There you go.
Okay,
that's a big one right there.
Radar reliable.
Okay.
6,000 feet above the surface now.
Altitude 2,000 meters. Altitude convergence detected. Altitude 1,800
there,
meters. 1,700 meters.
So far, everything has gone according to plan. You see Barry Goldstein trying to tell people to be quiet there because they're getting excited.
1,100 meters. Signal may drop out during lander separation. Altitude 1,000 meters.
Oh, yes.
The separation detected. We have
All right.
the signal. Gravity turn detected. Altitude 600 meters. 500 meters.
Are you watching the pictures?
400 meters.
Rocket motors are firing.
250 meters. 150 meters. 100 meters. 80 meters. 50 meters. Constant velocity phase detected. Altitude 40 meters. 30 meters. 27 meters. 20 meters.
Wow.
50 meters. Standing by for touchdown.
Literally, as you cross
Touchdown signal detected. Landing
They're down.
sequence initiated.
They're down.
Mars+lander.
Welcome back to Mars.
Whoa.
The Jet Propulsion Lab, NASA, the Mars Phoenix lander with a soft touchdown north of the Arctic Circle, the North Polar regions of the Red Planet, the first soft touchdown on legs of a spacecraft on Mars in more than 30 years. Since 1976, this hasn't happened. I asked Mike Griffin, the NASA administrator, a while ago how hard this was on a scale of 1 to 10. He said, oh, it's easily a 9.
Yeah.
They made it look easy.
That felt like a 10 to me. I don't know.
Wow.
Yeah.
That all went off without a hitch.
Yeah.
So now we're just going to want the whole process now of communication and seeing some images. Very soon, we're going to see Mars like we haven't seen it before, assuming everything's working. There's still some steps to go. We'll be back with more in just a moment. Stay with us.
They can find water here in the Arctic Circle.
Let's mission to Mars. The Mars Phoenix lander is on the ground. There's a lot of things that have to happen before we see pictures. They will come back a little before 10 p.m. Eastern time. First of all, take a look at the control room. A lot of congratulations going on in there. Steve Squires, what has to happen? What does Phoenix have to do to get ready to do science out there? There's a lot of things that have to happen now, right?
At this point, it's all about lander safety. The first thing that you want to do is make sure that the thing is safe on the surface. You release the helium to pressurize the propulsion system so you don't have to worry about that anymore. And then the big event is getting these solar
arrays right here. These two discs will kind of fan out, literally will fan out. And those things obviously have to work if this mission is going to succeed.
Right, but you don't do it right away because those rocket motors kicked up a lot of dust. And you got to literally wait for the dust to settle. So they're going to wait about 15 minutes, and then the solar arrays are going to come out.
Solar arrays deploy, the camera will pop up.
That's right.
The first pictures it will take are of the solar arrays.
That's
and
right.
then legs, and then eventually we'll see a horizon. I want to take you back 4 years ago to your scene when Spirit landed and those pictures came up. This is what we're going to see in just a little while if all goes well. When those first pictures come up, can you put it into words what that's like to you? All the years you spent trying to get to Mars, and you see those pictures.
It's an incredible feeling because on the one hand, you're looking at the hardware. You know, this was hardware that you were standing next to in Pasadena months before, and now here it is on the surface of Mars. But then you see Mars in the background, and it's just an incomparable feeling.
Yeah.